Set theory, examples 8 and 9. All right, what these examples focus on is if you're given a set, how many subsets can be formed from that particular set, and then how many proper subsets can be formed from that particular set. So we're going to start this discussion by first listing all the possible subsets that a set has, and then how many proper subsets a particular set has. Now, from what we have learned before, we should expect one less proper subsets than subsets, correct? Because you cannot include the set itself in proper subsets. All right, for example 8a, they want us to consider set D, and they want us to list all the subsets. Now, it's best to go about this in a very methodical way. A subset of set D that has two elements can either have 0 elements, 1 element, or 2 elements. It can't have anything more than that, right? So let's start with what would be a subset with 0 elements. Well, that would be the empty set. Okay? And then let's list the subsets with 1 element. Okay, that would be a set with 6 in it and a set with 8 in it. So we have 0 elements, the sets with 1 element, and then we have the sets with 2 elements. Okay, so that would be the set itself, right? And that would be all we would include. So on B, it says list all of the proper subsets of set D. And the hint is what should be missing compared to the subsets of D. Well, hopefully you would notice that we would be missing the set itself. Okay, so I'm going to go ahead and write down real quickly the rest of these particular subsets, everything but the subset itself. So I'm going to pause this and write those down. Okay, so we have the empty set, the set with the element 6, and the set with the element 8. And again, we will not include the set itself. Okay, so part C asks us to list all the subsets of set B. Now, set B, if you'll notice, has elements 4, 6, and 8. So we're going to do this methodically as well. Let's list all the subsets with 0 elements. 1 element, well, shouldn't we expect a subset with 4 in it, 6 in it, and then 8? Okay, there's our 1 element. Now we have to list all the subsets with 2 elements in it. So you can have a subset with 4 and a 6. Okay, and then let's link 4 with 8. Okay, now 4 has been linked to everything it possibly can, and so let's start looking at the 6. 6 can be linked to 8. Now 6 has already been linked to 4, so I'm done with all the subsets of set B that have 2 elements. And then the last one would have 3 elements, and that of course would be the set itself. Okay? So then D says list all the proper subsets of set B. Hint, what should be missing compared to, sorry about that, to the subsets of B. So hopefully you're saying, well, it can't be this set right here, which is the set itself, cannot be part of the proper subsets. So again, like what I did with example 8b, I'm going to pause this for a little bit and write down all the subsets of B, and hopefully you and I are getting the same thing. Okay, so 8D, you'll see a subset with 0 elements, 1 element, 2 elements, nothing with 3 elements, because that would be subset B itself. All right, so I would appreciate it if you would pause the video just for a little bit and try your best to list all of the subsets of C. And yes, it's going to be really hard. Well, not that hard. It's going to take some time, okay? So try to think it through for yourself and see what you come up with. All right, hopefully we came up with the same thing. So here's our 0 elements, 1 element, 2 elements, 3 elements, and then the last one would be the set with 4 elements. Before we go on, depending on your depth of your mathematics education, you may or may not have heard of something called the Pascals Triangle. And you'll notice the number of elements of a certain size in a subset seem to follow this pattern. If a set has 0 sets, like if it's an empty set, then yes, it's only going to have one subset with 0 elements. That would be itself. If something has 1 element, you're going to notice that it had 2 subsets, okay, and that's going to be the empty set and then the set itself. Alright, so if you'll look up at our examples above, the one with, I believe it was example 8a, we had something with 2 elements, okay? So you will notice that you had 1 empty set, that makes sense, and then you had 2 subsets with 1 element, and then you had 1 subset with 2 elements. Okay, so our set that had 3 elements, that would be set B. You'll notice it had 1 subset with 0 elements, 3 subsets with 1 element, 3 subsets with 2 elements, and 1 subset with all 3 elements. And then if you'll just look above in example E, you'll notice you had 1 subset that had 0 elements, 4 subsets with 1 element, 6 with 2 elements, 4 with 3 elements, and 1 with all 4 elements. So to get this Pascal's triangle, you'll notice when I start with the 1 at the top, I add the 1, and I get 2. Let me use a different color so it won't have so many different red marks here, okay? And then to get the next row, I think you see we put up the 1 on the outside. 1 and 2 is 3. 2 plus 1 is 3. And of course 1 on the outside. The last row we have 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And so if you're listing the elements, listing all the subsets of a particular set, it's kind of nice to know if you're missing any one of those subsets of particular size. All right, so let's go on to the next page to finish up our discussion of set C. So F asks us to state which of the sets listed in part E is not a proper subset of C. Well, that would be the set itself, correct? So the set with 4, 6, 8, and 10 would not be a proper subset of C. All right, so let's do a generalization from what we did here with the previous problems. So with G, it's asking us to complete the table using your work from parts A through F. So you'll notice that there were 2 elements in set D, and the number of subsets that set D had was 4. And 1 less of the proper subsets. In B, you had 3 elements. You had 8 subsets there, and of course 1 less proper subset. C had 4 elements, and you had 16 subsets there. Remember, we started to kind of run out of gas when we were listing them, and then you would have 1 less proper subset. So if we could generalize this, any set that has an n number of elements, we'll think, how do we get from 2 to 4, 3 to 8, 4 to 16? It looks like that it's going to be 2 raised to the number of elements in that set, so to the n power. And the number of proper subsets would be 2 to the n, and then of course we would take 1 away. So our generalization is for any set with n elements, there are 2 to the n subsets of set A and 2 to the n and then minus 1 proper subsets of set A. So it makes sense that there'd be one less because you can't have the set itself be a proper subset. Briefly, in example 9, I understand that this video is getting a little bit long. We're going to use those formulas we just found and how many subsets does a particular have or proper subset. It just depends on what they're asking. If set n has elements 1 through 10, of course that would be 10 elements, use a formula to determine how many subsets of n exist. So again, we said that there were 10 elements. So there are 2 to the 10th power subsets. Put that in your calculator. That's 1024, and I think you see why we're not listing all of those subsets. B says if set M is Andes, Rockies, Himalayas, Pyrenees, Appalachians. So it looks like set M has 1, 2, 3, 4, 5 elements. Use a formula to determine the number of proper subsets of set M. So that will be 2 to the 5th power minus 1. So that gives us 31. And then lastly, if set S is a set of states in the U.S., so right now there are 50, use a formula to write an expression. Your calculator just can't seem to do this particular calculation for the number of subsets and the number of proper subsets of S. So our subsets, well, that'll be 2 to the 50th power, and we're done with that. That's all they asked us to do is write expression. And the number of proper subsets, well, we know from experience that will be one less.